We now discuss the solution of a problem from the section Differential Calculus. The question is about counting the number of discontinuities of a given function in a given interval. This question has appeared in the joint entrance examination main held on 25th June 2022 in the second shift. The given question is, let f of x is equal to bracket 2x square plus 1 and g of x is equal to 2x minus 3 when x negative, 2x plus 3 when x greater than or equal to 0, where bracket t is the greatest integer less than or equal to t. Then the open interval minus 1 to plus 1, the number of points where f composed g is discontinuous is equal to. We are given two functions. F of x is equal to the greatest integer function of 2x square plus 1 and g of x is equal to 2x minus 3 when x is negative, 2x plus 3 when x is greater than or equal to 0. Agreed. Then we have to find in the open interval minus 1 to plus 1 the number of discontinuities of this function f composed g. So we have to count the number of discontinuities of f composed g in the open interval minus 1 to plus 1. That is our given question. Let's now discuss the solution of the problem in detail. We have f of x is equal to bracket of 2x square plus 1 and g of x is equal to 2x minus 3 when x is negative, 2x plus 3 when x greater than or equal to 0. Now compose f compose g of x is equal to f of g of x. That is in f of x substitute g of x. That is the bracket 2 times g of x whole square plus 1. That is equal to bracket 2 times of g of x square is 2x minus 3 whole square plus 1 bracket close when x negative and when x greater than or equal to 0 bracket of 2 times 2x plus 3 whole square plus 1 bracket close when x greater than or equal to 0. But our discussion is in the open interval minus 1 to plus 1. So this will be equal to the function defined as that is equal to f composed g of x is equal to bracket 2 times 2x minus 3 whole square plus 1 when x belongs to minus 1 to 0 open interval and bracket 2 times 2x plus 3 whole square plus 1 when x belongs to the interval 0 to 1. It is a semi-closed interval closed at 0 end because the discussion is in the open interval minus 1 to plus 1. Now let's see what happens at 0. What happens at 0? Suppose x tends to 0 from the left. That means you go and substitute here 2 times minus 3 whole square, that is 2 times 9, 18, 18 plus 1, 19. And when x tends to 0 from the right, you have to go and substitute x is equal to 0 in this, and then you will get 19 also in this case. That means the right limit and left limit at x is equal to 0 is equal and equal to 19. So limit x tends to 0 minus f composed g of x, minus means left limit, limit x tends to 0 plus means from right f composed g of x, both are equal to 19. Therefore, our function f composed g is continuous at x is equal to 0 and takes the value 19. So when we are counting when we are counting the number of discontinuities, we will not count x is equal to 0 because it is continuous at x is equal. That means we will not count 19. Agree? So we continue in the next slide. So that's what we have seen, and we have seen f composed G is continuous at x is equal to 0. Now note that x belongs to -1 to 0 open interval, -1 to 0. So suppose you that means you substitute -1 to 0 means in this 2 times 2 into -1 -3, that is -5 whole square, that is 2 into 25 plus 1, 2 into 25, that's 50 plus 1, 51. So it starts from 51 and ends with x is equal to 0 means in this x is equal to 0 means it is 19. So that means it starts from 51 and comes down to 19. That means it is a decreasing function in this interval -1 to 0. Anyway, we have to count the number of discontinuities in the intervals. So therefore we take the open interval 19 to 51. But it's actually dropping from 51 to 19. Agreed. So as x belongs to the open interval -1 to 0, the number of discontinuities of f composed G of x in the -1 to 0 means in the first branch, that is this one, is equal to the number of integers in 19 to 51. The number of integers in the open interval 19 to 51. 19 is not taken, 51 is not taken. The integers in between 19 and 51, they are 31 in number. Why? Because the bracket function is discontinuous at integral values. So therefore, we count the integers in this. Agreed. As note that x belongs to the open interval 0 to 1. So one may ask a question, sir, x belongs to the semi-closed interval 0 to 1 and the closed at 0 end, but now we are taking the open interval. Why? Because at x is equal to 0, it is continuous. Therefore, we cannot take it because we are now counting discontinuities. Therefore, we will count x belongs to 0 to 1. So if x takes the value 0, then it will take 19. You agreed? When x takes 1 in this, it will take 51. That means 19 to 51. So it will map. So that means it is an increasing function. In this, it's an increasing function. So therefore, as x belongs to the open interval 0 to 1, the number of discontinuities of f composed G of x in this branch, second branch, is equal to the number of integers in 19 to 51, and they are 31 in number. So that means you have to count from 20 onwards. 20 to 20, 23, 24, 25 up to 50. They are 31. And 51 you are not supposed to count. 19 you are not supposed to count. 19 you are not supposed to count because at x is equal to 0 it is continuous. And right. So we have now found the number of discontinuities. So 31 plus 31, that is 62. The number of discontinuities of f composed G in the open interval -1 to +1 is equal to 31 there, 31 here, that is 62. That's your answer. So this is an interesting question, very, very interesting, and the students may find it difficult in the examination, but some of the students, so they are all JEE students, many of them are brilliant students are there, they may work out, but an average student may not be doing in the examination unless he has already done such a similar problem. So that is the detailed discussion of the solution of the problem on the counting the number of discontinuities of a given function in a given interval. I am sure that you have understood the solution of this problem. I wish you all the best. Thank you.